China makes more stuff than any other country on the planet. Phones, cars, furniture, clothes, electronics, solar panels. If it can be built, China is probably building it. But here's the part nobody talks about. Everything eventually breaks, wears out, or becomes obsolete. Multiply that across more than 1 billion people and decades of non-stop manufacturing, and you get mountains of waste piling up everywhere. Here's the twist. Instead of quietly burying it all, China has been building an entirely new industry around taking that waste apart and squeezing out the value hidden inside it. And some of the technology involved is so advanced that scientists studying it keep saying the same thing. They did not expect it to work this well. Machines that grind dead batteries into a gray dust worth more per gram than raw mined ore. Machines that peel apart solar panels to rescue slivers of silver too thin to see. Machines that crush entire demolished buildings into gravel and pave roads with it. This is not a small pilot program. This is a full industrial transformation, and researchers around the world are watching it closely. This isn't really a story about saving the planet, even if that's a nice side effect. It's a story about turning garbage into one of the most valuable resources on Earth. A dead car battery, a cracked solar panel, a demolished building, an old cotton shirt, and a bag of food scraps are all getting pulled into the same giant system. If you like videos that dig into details other channels skip, hit the like button. It genuinely helps. And subscribe so you don't miss what's next. Let's start with the strangest gold mine on the planet. It isn't underground. It's sitting dead in a garage. Think of an electric car battery as a locked treasure chest. Most people see a heavy, useless black brick once the car stops working. But inside is a dense mix of metals that mining companies spend billions digging out of the earth. Lithium, nickel, cobalt, manganese, copper, aluminum, already refined and packed neatly into one unit. Someone already did the hardest part of mining. The box is just sitting there, waiting to be opened. China's process starts with safety. Every dead battery gets logged and checked. Any leftover charge is drained first, because a charged battery that gets crushed can catch fire or explode. Once it's safe, workers check whether it still has life left. A pack too weak for driving might still work fine storing solar power in a shed for a few more years. That buys time, but it doesn't solve the real problem, because every battery dies eventually. When that happens, workers break the pack into smaller pieces and feed them into industrial shredders that tear through metal casing, plastic, and wiring. What's left is a fine, dark powder called black mass, the concentrated heart of the battery. Chemical processing separates the metals back out into pure materials that go straight into new batteries. A battery made from a battery. The scale is staggering. China handles an estimated 70% or more of global battery recycling. For shredding specifically, that number climbs closer to 80%. For final refining, some estimates put it near 90%. This isn't a country dabbling in recycling. It built the recycling backbone for the entire planet. The rules keep shifting too. A new national standard for black mass took effect in mid-2025. Shortly after, black mass meeting that standard stopped being classified as hazardous waste and became a tradable product instead. While other regions tightened restrictions, China opened the gates. But the story is messier than headlines suggest. Batteries loaded with nickel and cobalt are highly profitable to recycle. Cheaper batteries are far less attractive. And there's an uncomfortable truth behind the polished factories. Licensed recyclers with proper safety equipment reportedly run at only 20 to 30% of capacity. Not because batteries are scarce, but because unlicensed workshops pay more since they skip safety gear entirely. The legitimate plants sit ready while batteries disappear into informal channels. So the system is real and enormous, but running at half capacity. At least batteries are valuable enough to justify the expensive equipment. The next material isn't so lucky. It was engineered from day one to resist ever being taken apart. Now let's talk about the puzzle that has scientists genuinely stumped. Old solar panels. A panel that spent 30 years on a roof isn't a clean energy symbol anymore. It's roughly 20 kilograms of glass, plastic, and metal fused into one sheet that refuses to come apart. By weight, it's mostly glass and aluminum framing, but by value, everything flips. More than 60% sits in a razor-thin layer of silver buried inside the silicon cells, invisible until you tear the whole thing apart. On paper, recycling sounds simple. Remove the frame, disconnect the wiring, collect the glass, then separate the silicon, copper, and silver. In reality, you're fighting 30 years of deliberate engineering built to survive rain, hail, frost, and sun. That same durability makes the panel nearly impossible to disassemble afterward. Most recycling today barely touches the hard part. The frame and glass come off easily, but the silver is trapped between layers of plastic and silicon, requiring extreme heat or aggressive chemicals to reach, both expensive and energy intensive. And this wave is coming on a predictable schedule. Estimates suggest China could see around 18 gigawatts of retired panels piling up by 2030, roughly 1.4 to 1.5 million tons of material. By 2040, that could reach over 250 gigawatts, or about 20 million tons. China installed a massive number of panels in a short window, so they're all aging out at once, like an entire neighborhood needing new roofs the same year. Solar panels are a story about materials fused together too tightly. The next waste stream is the opposite. It arrives in millions of loose pieces, and its sheer volume dwarfs everything else on this list. By pure tonnage, construction and demolition waste is the biggest pile China produces. Nothing else comes close. Demolished buildings leave behind concrete, steel, brick, asphalt, glass, wood, drywall, insulation, and unidentifiable debris. Compared to battery chemistry or solar adhesives, this process is almost simple. Trucks haul rubble away, workers pull out reusable material, magnets grab steel, and crushers pulverize the rest into gravel used for road bases and fill. The simplicity is exactly why the numbers are disappointing. In 2020, China produced an estimated 2.6 billion tons of construction waste. Only about 312 million tons were recycled, roughly 12%. The overall recovery rate sits below 40% nationwide. For comparison, the US produces far less construction waste, but reportedly recovers close to 75% of it. Chongqing alone generated 167 million tons in 2021, more than half its total solid waste, with a recovery rate under 30%. Why does something this simple perform so poorly? Money. Crushed gravel sells for almost nothing, and dumping rubble is often cheaper than crushing it. Quality is the other obstacle. Rubble from messy demolitions is full of surprises like drywall and wiring, unsafe for structural use. So most recycled gravel ends up under roads, where the only requirement is that it stays put. Construction waste is a story about volume. The next material hides enormous value in pieces smaller than a grain of rice. Here's a fact that sounds fake but isn't. A ton of gold ore might yield a few grams of gold. A ton of old circuit boards can yield significantly more. The richest gold deposit near any Chinese city isn't underground. It's sitting in drawers and boxes full of dead phones. People call this urban mining, and it's a genuine statement about how much metal is packed into old electronics. Copper, aluminum, steel, gold, silver, palladium, plastic, glass, and rare metals most people have never heard of. The recovery process runs like an assembly line. Workers remove batteries and hazardous parts first, then dismantle by hand or machine. Magnets grab iron and steel. Eddy current separators flick out aluminum. Optical scanners sort what remains, and smelting or chemical processing pulls out pure metals. China has pushed hard to formalize this. Between 2024 and 2025, an estimated 53 million used appliances and phones entered standardized dismantling channels, growing about 12% a year. One licensed plant in Fujian processes more than 2,000 dead appliances daily, splitting each one into separate streams of plastic, metal, and foam. The economics here actually work. Gold and silver are valuable enough to justify sophisticated recycling facilities. If a ton of circuit boards contains more gold than a ton of raw ore, the financial case builds itself. The next material is far more stubborn. Its raw components are cheap, dyed, stitched from 5 fabrics at once, and nearly impossible to separate. Check the tag on any shirt in your closet. If it says 100% cotton or polyester, that's an easy problem. But if it's a cotton polyester elastane blend with a printed logo and a metal zipper, you're holding something almost no technology on Earth can turn back into a new shirt. Purity is everything, and modern clothing is deliberately impure. Every stretchy, soft, color-fast feature comes from blending fibers, and blended fibers are exactly what makes recycling nearly impossible. Reselling or repairing old clothing is the best outcome. Shredding fabric into stuffing counts as recycling technically, but it's a one-way trip downhill. Fibers get shorter each cycle until they can't hold together at all. The exciting frontier is chemical recycling, breaking polyester down to its basic building blocks and reconstructing it from scratch. One Chinese company reportedly produces recycled DMT, a core polyester chemical, at 99.9% purity, with capacity around 50,000 tons a year, projected to hit 500,000 tons of regenerated fiber by 2030. The catch is, it only works on pure polyester. Separating cotton from synthetic fiber cheaply remains a massive headache. In 2020, China generated an estimated 22 million tons of textile waste and recycled only about 20% of it. Official targets aim for 25% by 2025 and 30% by 2030. Even the most ambitious goal admits 7 out of every 10 garments never come back. The next material starts decomposing within hours of being thrown out, and that rapid decay is exactly what makes it useful. Food waste is the stream everyone forgets. In Shanghai alone, wet waste reportedly made up around 60% of household garbage. It's also the worst thing to mix into other trash. Heavy, soggy, and it ruins everything dry it touches, while lowering the energy content of material meant to be burned later. Pulled out of the mix, though, things improve. The technology is anaerobic digestion, organic waste sealed in an oxygen-free tank where bacteria consume it and release biogas, mostly methane and carbon dioxide, which can be burned for heat and electricity or upgraded into vehicle fuel. The leftover digestate can potentially become fertilizer, though it can carry pathogens and heavy metals, and salty Chinese cooking makes salty compost less useful for farming. The turning point came July 1, 2019, when Shanghai made household waste sorting mandatory, splitting garbage into 4 bins: food waste, recyclables, hazardous materials, and residual waste. Fines reached 200 yuan for residents and 50,000 yuan for businesses. This is a city of over 24 million people, producing about 30,000 tons of waste daily. People complained loudly at first. Then it worked. Sorted food waste jumped from about 4,000 tons a day to a steady 9,000 to 10,000 tons, arriving at processing plants at 99.5% purity. Recyclable collections surged, hazardous waste recovery rose more than tenfold, and residual waste dropped about 20%. With the wet material gone, dry trash carried nearly double the energy content, making it far more efficient to burn. The most powerful tool here wasn't a machine. It was a law that told 24 million people which bin to use. Even after all that reuse, sorting, recycling, and digesting, a large pile still remains. What happens to it next is the most misunderstood part of this story. Burning trash is not recycling. It's waste treatment with energy recovery. It shrinks volume, generates electricity, and lets some metal be recovered from the ash. But the core materials never return to making new products. A plastic bottle burned in an incinerator will never be a bottle again. China's incineration network is genuinely stunning in scale. By the end of 2024, the country reportedly had 1,129 waste-to-energy plants running, with combined generating capacity over 27 gigawatts, producing about 145 billion kilowatt-hours of electricity, with treatment capacity exceeding 1.1 million tons a day. Research suggests these plants supplied up to 7% of China's residential electricity needs in a recent year, enough to power millions of homes. By 2023, more than 78% of city trash went to incinerators, while landfills shrank to about 13%. The old image of Chinese cities ringed by sprawling dumps is out of date. The furnaces have taken over. A modern plant burns trash at extremely high temperatures, boiling water into steam that spins turbines, while layers of filters, chemical sprays, and activated carbon clean the exhaust before it ever leaves the chimney. And it all ties back to the sorting revolution. Removing wet food waste first means what's left burns hotter and cleaner. Sorting makes burning better, and burning handles what sorting can't recycle. Put it all together and you get a massive industrial machine, imperfect in places, especially with mixed plastics and construction rubble, but moving in a clear direction. The country that manufactured more goods than any other nation on Earth is now building the systems to take those same goods apart once their time is up. That might be one of the biggest industrial challenges of the coming century. If you enjoyed this breakdown, hit the like button, subscribe, and turn on notifications so you don't miss the next one. So here's a question for you. If you were building a nationwide recycling system from scratch, which of these would be hardest to solve? The batteries, the solar panels, the construction rubble, or the old clothes in your closet? Let me know in the comments. Disclaimer: this video is created strictly for educational and informational purposes only. It reflects personal commentary and opinions based on publicly available information gathered from sources such as YouTube, Google, news outlets, and other public reporting. It is not intended as professional, scientific, financial, or investment advice, and viewers should conduct their own independent research and consult qualified experts before making any decisions based on the topics discussed.